Andrés Fuster-Guillo, that is the head of the Applied Intelligent Architecture Research Group at the University of Alicante. He will present, or he's going to present the DeepFish project, that is a computer vision and deep learning for fish markets. It's in the same application on fish auction of the catches, on identifying these and quantifying these catches. So, Andrés, thank you for participating in this forum, and go ahead, please.
Hello, good morning, everybody. I don't know if you can see my screen, please.
Yes.
Yes. Can you see my presentation?
Yeah.
Yes. And can you listen properly?
Perfect.
Okay. Thank you very much. I'm going to begin. Okay. First, I'm going to thank you very much, the organizers, for your kind invitation to this SICAPTOR forum. And let me mention the funding organization, the Fundación Biodiversidad, in the PLEAMAR program, that is the funding organization of this project that I am going to talk about. My name is Andrés Fuster-Guillo. I'm the head of the Applied Intelligent Architecture Research Group from the University of Alicante. And I'm going to present the results of the project with the acronym DeepFish. And the title of the project is Species Identification in Fish Markets Based on Deep Learning. We are a computer science group with experience in computer vision. We are beginning in this area of application of fishes, and we are collaborating with the Instituto de Ecología Litoral from Campello. And this is the outline of the presentation. First, we are going to talk about the objectives of the project. Then we will talk about the data set that we are elaborating to do the training. Then we will talk about the deep network architecture for species identification. We also will talk about the size estimation, the problem of size estimation, the development of the vision system prototype, and finally some contributions and conclusions to summarize the contributions. And we will talk only a little about our future project that is we are applying now, that is DeepFish 2. Then let's go with the objectives. The main objective of this project has been running from December 2020. Then now we are at 1 year of project. And the main objective is the development of a deep learning based machine vision system to try to identify and measure fish species from fish markets, in particular from the area of Cabo Las Huertas in Nature 2000 network. And to face this objective, we have organized 4 specific objectives. First one is to elaborate this data set with species and size, labeled with species and size. The second objective is to organize the deep network architecture, to perform the deep network architecture for the species identification and measurement. The third objective is to develop the development of the vision system for automatic species classification and measurement. And the last objective is the deployment of this vision system in a fish market. In particular, we are going to work in Campello fish market. We are working in Campello fish market. Then, related to the dataset, we are storing a big dataset with a large number of species. We have take pictures in the period from May to September 2021 for more than 1,000 tries with fishes, and we have labeled the order of 9,000 fishes organized in 18 species. And as you can see in the graph, 13 of these species have more than 100 instances. Then we focus the training of the network in these 13 species that we have enough instances to try to do the segmentation. Then the problem that we want to face is called instance segmentation, that is detecting and delineating each fish appearing in the image. Then to do so, we have selected a popular framework called Django Labeler, and we have adapted this framework for the fish segmentation and for the labeling at the pixel level. And we have introduced labels for the different species and also labels for the size of the species in the images. Then the output for this of this software is a file in JSON format with metadata about the segmented pixels areas and the corresponding species and sizes that we get during the labeling process. And we have adapted this output file to YOLACT, that is the framework that we are using as the deep neural network, in particular to COCO dataset format. Since we want to face the problem of size, we have to do the size labeling, and then we have also adapt Django labeler to measure the length of the fishes using segments or sequence of segments to try to get the more precise measure of the fishes, and we have estimate the scale of the image using the tribes of fishes as since we know the measure of these tribes, we use as the marker to calculate the scale, and then we apply transformations, in particular homography transformations, to try to correct some deformations that we have in the image. Okay, regarding the deep network architecture for species identification, we have selected YOLACT. This is a fully convolutional model, very with good results for real-time instant segmentation. It's framework based on YOLO. We have been studying different parameters and issues about this deep neural network architecture. For example, training different configuration of layers and balancing the classes, adding different sampling to face the problem of unbalanced classes. We have tried with different backbone networks. Now we are working with ResNet 50 with different pre-trained weights, with different data sets. Now we are working with ImageNet, and we have worked with the problem of data augmentation with photometric distortion, incorporating photometric distortion, scaling, random, crop, mirror, and rotation to try to improve results. Then here you can see some numerical results of the training and recognition process. We have used the mean average precision, and you can see like how the mean average precision for all classes reached the 77%. You can see that 10 species are over 77% in our data set, and considering the 10 better species, we reached the 83.6% regarding mean average precision, and the 3 species between 50% and 70% have low number of instances of the explanation about the performance. Here you can see an example of the labeling results with the bounding boxes, the segmented fishes, and the class of species obtained in each bounding box. Regarding the size estimation, here you can see the pipeline that we are using to measure the fishes. First, we use YOLACT to get the bounding box of the fishes and the species level. Then we extract the bounding boxes and train a support vector machine. This support vector machine takes as an input the normalized bounding boxes and the classification of the species with the class, and as the output, the ground truth size that we have previously stored in our dataset. Then, once the support vector machine is trained with the bounding box and the species, we perform the estimation of the size. Now we are finishing the tests of this method and try to analyze the precision that we are getting with this method. Okay, regarding the vision system, we are finishing the development of a vision system using NVIDIA Jetson Nano. This is a single board computer and an AGV camera to deploy the system in the Campello fish market. And we have adapted the deep neural network software to run over this Jetson Nano. And the system takes the inputs for the systems are RGB video image with the fish try and the QR codes of the fishing boats. Then the output of the system are the real-time labeled image viewed on the screen, and we are updating a data set with the data of fishing boat, species, size, etc. That is the data set that we are going to explode in the future. Here in the image, you can see on the left the input to the system, video image and QR images. And on the right, you can see the output of the system with the real-time labeling, where we are applying a voting method to try to decide the labels that we finally store on the database that we are storing with all the tries and the fishes and its sizes. Okay, finally, to summarize the contributions, we are working in a fish species dataset using the Django library to introduce the metadata related to the species and the sizes. We are working with a deep network architecture for species identification, in particular with YOLAC, with good results regarding time performance. We are proposing a method for size estimation based on the use of YOLAC and support vector machines. And we are developing the vision system prototype using Jetson Nano to try to deploy these systems in real markets, in particular to the market near here. Then now we are applying for a new project that is DeepFish DOS, and the main objectives of this future project will be the extension and dissemination of this dataset, the adaptation of the vision system to new fish markets, the adaptation of the deep network architecture to these new species and markets, the development of a module for the dataset analytics. This is very important because it's the main goal in long term for the project, and the deployment of the vision system in new fish markets in the Nature 2000 network. And we also want to continue this very valuable question with collaboration forum on the recognition and sizing of marine species using artificial vision. Then this is all. Thank you very much for your attention.
SICAPTOR, monitorización electrónica para una mejor gestión.